Hey everybody, Trey here. Welcome back to another video. Devastating night for folks of Southern California, particularly the Los Angeles metro area, as multiple intense wildfires have burned across inhabited areas of the LA metroplex. Places like Pasadena, Malibu have seen several homes destroyed, lots of infrastructure burned by these fires. So just a devastating event thus far across Southern California, and that is expected to continue through at least the afternoon today. And hopefully firefighters can get some containment from these fires out there over the next couple days. Just some incredible images coming out of these areas. Here's an aerial view of Malibu and Pacific Palisades just engulfed in flames. Just some real jaw-dropping images coming out of these areas. This is what we have going on right now as far as fires go. This was posted about an hour and a half before I recorded this video, just before 8 a.m. Pacific time. We have 4 separate fires of note that have burned almost 6,000 acres in total, likely more at this point, and they will likely continue to expand pretty rapidly, especially as conditions are expected to remain pretty favorable for fire activity going into this afternoon today. But the 2 fires of note in particular are the Palisades fire and the Eaton fire out here, a combined 5,000 plus acres burned by those fires, with a couple of other notable ones as well. So just a devastating scene out there. And this is what we have going on for today as far as fire weather from the Storm Prediction Center. We have an extremely critical fire weather area in the pink shaded region there. So Oxnard, Santa Clarita, Burbank, the northern and northwestern portions of the Los Angeles metro area, Malibu in that as well. So unfortunately, the conditions are not expected to let up anytime soon. But I thought it'd be interesting to do a little bit of a brief video on just why these fires are occurring. This is not all that uncommon of a setup for Southern California, and the confluence of topography and meteorology really make these fires tick across this region. So I thought it'd be interesting to do a little bit of a deep dive into into the meteorology behind these fires and see why they've been so destructive. You can see on satellite imagery as well, these black spots here on our infrared satellite imagery, those are our fires. You can clearly make them out as well. In our true color imagery, the orange spots there, not much explanation needed right there in the foothills of the LA metro there. Those are our fires that are burning on visible satellite imagery. And so just pretty jaw-dropping stuff here this morning as these images flow in. So these fires have started and spread because of a fairly common phenomenon across this region called the Santa Ana winds. And the Santa Ana winds are most common during the fall and winter months, particularly October through about February or March. They can occur any time of year, but again, most commonly they tend to occur in the fall and winter months across the Southern California region. So, as we said before, there is a distinct geographical component as well as a meteorological component to these setups. Let's start off with the topographical component. I have a topographical map of the western and southwestern U.S. here. The reds, browns, and whites represent higher elevation areas, and the greens, yellows, and blues represent lower elevation areas. So out here across Nevada, Utah, northern Arizona is a feature called the Great Basin. And the Great Basin is a topographical feature. It's generally referred to as sort of a plateau. It does have a basin and range topography. So you have your basins, which are your flatter areas, like your Death Valley type areas, increasing to your higher sort of mountain peaks within these regions. So it's a varied topography within the Great Basin. But overall, it is referred to as sort of a plateau that lies generally at higher elevation. Much higher elevation than areas down here to the south across Southern California. We do have the mountain ranges here just to the north of Los Angeles, which come into play. We'll talk about that here in just a second, the Santa Ana Mountains there. But overall, your elevations near the coast, far Southern California, those are areas of much lower elevation. So you have a very distinct topographical difference between the Great Basin, which is at higher elevation, and lower elevation down here to the south. What tends to happen is that we get an area of high pressure to develop across the Great Basin region. Here is our SPC mesoanalysis page, the surface data, current surface data across the U.S. And as you can see, much higher pressures here across the Great Basin compared to areas farther south where a bit of a surface low has developed. Out across the Gulf of California, we've seen a surface low develop. That is at the hands of a bit of an upper trough that has swung through. Very strong closed low down here with very strong winds rounding the base of that closed low, moving across the Baja California Peninsula. And so we've seen a little bit of a low-level response with that in the form of surface low development in the exit region of that trough. So again, we have high pressure here off to the north across the Great Basin, much higher pressures here compared to areas farther south where we've seen that surface low develop. Around an area of high pressure, we have clockwise flow, and around an area of low pressure, we have counterclockwise flow. That leads to more easterly or northeasterly winds funneling into Southern California. Generally, we have more southerly or southwesterly flow, onshore flow as we call it, moving inland from the moist Pacific, leading to a much more moist low-level air mass. But because these winds are coming from the east or northeast, where the air is much drier, we're funneling in much drier air down here in what we call offshore flow, emanating from areas inland, that we see much stronger offshore flow and drying overall, at least on the large scale here. We'll go back to topography here in just a second, but this is what happens when you have these contrasting pressures here. Also what happens, as we talked about before on the channel, the surface winds are modulated by the pressure gradient. And when the pressure gradient increases, our surface winds increase. So we have high pressure here again off to the north across the Great Basin, centered somewhere in the northern Nevada, northern Utah, southern Idaho vicinity, with our surface low down here to the south across the Gulf of California. This is a fairly quick, fairly rapid change in pressure over a fairly short distance. And as a result, the pressure gradient has increased. And so you see the isobars here, our pressure contours, very tightly packed, very close together. That means we have a very tight pressure gradient, and the pressure gradient flows from higher to low pressure. And so we have a general flow from north to south across these regions, higher pressure toward lower pressure. And because the pressure gradient has tightened, we've seen a strengthening of the surface winds, at least on the large scale. So we've established that the winds tend to flow into Southern California from the east or northeast in these Santa Ana wind events because of the flow around the pressure centers and the tightening pressure gradient from high to low pressure from higher terrain to lower terrain. That induces downsloping winds. So as that flow comes in off from the northeast or east, it comes from the higher terrain to the lower terrain. That is flowing down the slope, and therefore, hence the name downsloping winds. As winds flow from higher elevations to lower elevations, they become compressed and they warm. So as we talk about a lot in severe weather setups, air tends to rise, and that as air rises, it expands and cools. The opposite is true when air sinks. And that's why high pressure areas, which promote sinking motion, are unfavorable for storm initiation and severe weather, because air tends to sink in those high pressure centers. And as a result, that air compresses, it becomes smaller, and it warms, unlike rising air, which expands and cools. So as the flow comes down from the higher terrain to the lower terrain of Southern California, out of the east or northeast, it flows down the slope, and therefore it compresses and it warms. As it warms, and again, because the winds are coming from not a moisture source here, very dry air from the Great Basin, instead of our typical onshore flow coming from our moist ocean, our winds are warming and they're losing moisture. So that is a recipe for creating creating the meteorological environment for very dry, downsloping winds across these regions. So that is how the winds tend to strengthen. But what is interesting about the Santa Ana winds is that the localized terrain in and around Los Angeles plays a huge role. So as the winds come down the slope here, they encounter the big mountain range there in eastern California, the Sierra Nevadas. And they just don't have enough energy to fully get up and over those mountain ranges. The Sierra Nevadas are very, very tall mountains, so the wind oftentimes does not have enough energy to get over those mountain ranges. So those Sierra Nevada mountains act as sort of a blocker. They kind of reroute or divert the flow down to the south toward the general area of Los Angeles. At that point, those winds encounter the mountain ranges just on the north side of Los Angeles. The San Gabriel's there, the Santa Ana Mountains right there. And this is where things get interesting. So what happens is the flow that is already starting to dry and warm as it encounters that downsloping effect from higher terrain to lower terrain, they encounter the mountain ranges of Southern California there near Los Angeles. And as the flow moves through the narrow channels and passes in the mountains, the wind accelerates. So if you have these downsloping winds at 20, 30 miles an hour, they can really ramp up to 50, 60 plus miles an hour as they are funneled through these very tight channels and passes of the San Gabriel and Santa Ana Mountains. This is called the Bernoulli principle. Basically, as flow is channeled through a very small area, the pressure decreases and the winds tend to sort of conglomerate and increase and accelerate across those areas. And that is what is happening here. As the wind goes through these very narrow mountain passes and channels, the wind accelerates. And that is how we get very strong winds in these Santa Ana wind events. Another component to that is called the mountain wave effect. And what happens is when wind comes in sort of perpendicular to the higher terrain, which is what is happening here, your higher mountains oriented west to east, your wind coming in from the north or northeast. So those winds are kind of perpendicular. They're running into those higher mountain ranges on the north side of Los Angeles. As that happens, that air is forced up and over the mountain peaks. I'll draw a little bit of a vertical depiction here. So here is the ocean over here, and LA is kind of down in here. So here are your San Gabriel Mountains right here. The wind is coming in, and it's forced up and over the mountain peaks, and that creates a mountain wave effect. And just as a river that flows or a stream that flows around a stationary big boulder, downstream of the boulder, you get sort of these waves in the flow that occur. Same thing here. As that flow is forced up and over the tall mountain peak, you get a wave. You get wave action on the lee side or the opposite side, downstream of where the wind is coming from. As those waves can cause significant turbulence for aircraft, and if those waves reach the surface, which in this case they do, you can get very, very strong winds at the base of those waves, those troughs there. So as it reaches, you get the wave action there, you get the base of these waves to hit the surface. Very strong winds can lie in a narrow area within these wave troughs as they intersect the surface. So you have the downsloping effect and the channeling of the flow through the mountain passes of the San Gabriels there. That helps to accelerate the flow. And what helps to further accelerate the flow is this mountain wave effect. As these waves, as the wind flows over the mountain peak, you get these waves on the lee side of the mountains. And as those waves, the troughs intersect with the surface, you get very narrow swaths of intense winds and even faster winds than what were already being observed in those areas. So that is what leads to these very, very strong winds in the foothills of the San Gabriels on the northern and northwestern sides often of Los Angeles. To summarize here, you have your downsloping winds warming and drying as they come down here. They're sort of blocked by the Sierra Nevadas. They come down and interact with the mountain range just north of Los Angeles. It's funneled through those mountain passes. That helps the wind increase. And as you get that mountain wave effect, the winds further increase. And that's why we've seen wind gusts of 70, 80, 90, 100 plus miles an hour in some of these areas, making it very, very favorable for fires to spread. And of course, for fires to start, we need a lot of fuel, dry vegetation, timber, etc. And in Southern California, that has been an issue lately. We've seen an increase from the start of 2024, especially, and even over the last couple of weeks, we have seen an increase in drought across the Southern California area. It could be worse, I will say. We're not seeing any severe to extreme drought across this area, but we are seeing some abnormally dry to moderate drought across the general vicinity of Los Angeles. You see the yellows and oranges there indicate your abnormally dry to moderate drought conditions there. And again, that has been on the increase over especially the last year, but also the last couple of weeks as well. And so we do have quite a bit of fuel in place for those fires to feed off of. So let's see how all of that played out in this particular case. We'll look at some SPC mesoanalysis data beginning at the surface at 12Z, 5 a.m. Pacific time yesterday morning. So starting at Tuesday morning, January 7th, going through the morning today as we're recording this video. So Right here you see our surface low beginning to develop across southwest Arizona, northwest Mexico with the passage of the upper level trough. We saw that low level response as well. High pressure shunted a little bit farther off to the north, more so across the far northwestern reaches of the U.S. Pressure gradient starting to increase here. Those isobars somewhat tightly packed across this corridor. You see the beginnings of those northerly winds off the higher terrain there of the Great Basin. Initially, winds across Southern California, not all that favorable for significant fire activity, but as we went into the afternoon and evening yesterday, that pressure gradient really increased. We saw widespread northerly and northeasterly winds take shape across that corridor, and that is what initiated the intense fire event there across Southern California, and that has persisted through this morning as well. We see that surface low continue to deepen a little bit there across Southern California, Southern Arizona, northwest Mexico. Pressure gradient continues to intensify there. Those isobars really become packed across the higher terrain of Arizona and especially into California as well. Again, broad area of northeasterly to northerly flow. Textbook look for a Santa Ana wind event, and that has continued into this morning. This is 12Z this morning, so 5 a.m. this morning, a continuation of those northeasterly winds. The surface low continuing to move off to the southeast a little bit. We will see a relaxing of the low-level winds and the pressure gradient going into mid to late afternoon today, so we will see a little bit of a respite across these fire-stricken areas, but overall the pattern has been pretty textbook for a Santa Ana wind event across Southern California, with our features in place, that high pressure taking shape here across the Great Basin and our low pressure area as a result of that mid and upper level trough there across western Mexico, really increasing that pressure gradient, increasing that downsloping flow, and funneling that into those mountain passes of Southern California. And with that downsloping flow came a significant drying of that surface air. As you see, to start the day yesterday here with our raw surface data, we had low dew points for most areas of the U.S., but for this area, not all that favorable for a significant fire event. Dew points in the 30s and 40s across Southern California. But watch what happens as we get that Santa Ana wind event to take shape. We see a significant increase of those winds out of the north and northeast, and those dew points begin to crater starting yesterday afternoon. Dew points in the 30s. Watch what happens as we get that downslope drying flow into these regions. Dew points absolutely crater across these areas into the teens by yesterday evening. Dew point of 12, 18, 14, 19, 17 there. So our moisture content dropped off significantly as we went into yesterday evening when those fires really started to go on their rampage, because we'd replaced that moist onshore flow with drying downslope flow, dry air initiating emanating from the Great Basin. You see there the dew points very, very low across that region initially, dew points in the teens and 20s across Nevada into Utah, with those northerly winds taking shape that just funneled all of that air along with our downslope drying process into Southern California to really crater that moisture, crater those relative humidities into the teens, which is, of course, when you have such dry background conditions, that is more than favorable for significant fire activity and fire spread. And those very low dew points have continued. We even saw some dew points approaching the single digits here in these areas. I believe that's a dew point of 6 right in there, dew point of 10. So very, very low dew points as those winds made their way across the San Gabriels to the north of Los Angeles, and that has persisted into this morning and will continue into this afternoon. Very dry conditions, very strong winds. And it is just a textbook setup with a lot of dry fuels in place for a significant wildfire event. So that is just a brief overview of what has happened with this particular event. Again, jaw-dropping images coming out of these regions, and hopefully the firefighters can get some containment of these fires soon. It's going to be a battle going into at least mid-afternoon today, as those winds and that Santa Ana wind event are going to continue its stronghold on the region through the afternoon. And that is going to make it very difficult to fight these fires, and we'll likely see quite a bit of fire spread with lots of dry fuels and those dry, windy conditions with very, very strong winds at the surface. Again, just to recap for you, high pressure off to the north across the Great Basin, low pressure down here to the south, leading to a strengthening pressure gradient, and of course that flow around these pressure regions, these areas of high and low pressure, have funneled those winds significantly into Southern California out of the north or northeast. That the pressure gradient strengthening strengthens those winds as they run into the mountain ranges to the north of Los Angeles. They've already been in the process of significantly drying, bringing that very dry air to the north into the region, and also drying as they come down the higher terrain into the lower terrain. But as they encounter those mountains to the north of Los Angeles, they get funneled through those mountain passes to really ramp up those winds, and of course the mountain wave effect as well. Significant turbulence reaching the surface there enhances those winds even further, 70, 80, 90, 100 mile an hour wind gusts across these areas, leading to very significant fire activity and fire spread. So hopefully you learned a little something about why these Santa Ana wind events take place and what has been behind this significant fire activity across Southern California the last couple of days. Again, hopefully they can get things under control here soon, but it's going to be a tough battle as these strong, dry winds are going to continue to have their stronghold across Southern California through at least mid-afternoon today. Hopefully we'll see some relaxing of that sooner rather than later, but it is going to be tough sledding for the next several hours. So that's going to do it. Thanks for watching, and we'll see you in the next one.